Okay, today's lesson we're talking about infinite limits. Our essential question for today is what does it mean when we say that the limit of f of x as x approaches a is infinity? So let us investigate the behavior of 1 over x, the function f of x is equal to 1 over x. We want to find the limit as x approaches 0 of f of x, both from the left and from the right. Let's start with the right. Limit as x approaches 0 from the right of 1 over x. We will find this numerically. X, 1 over x. So we will start with, let's say 0.1. 1 over x will be 10. 0.01, 100. 0.001, 1000. We now see that 1 over x is getting bigger and bigger. So let's get even closer to 0. 0.0000001. 1, 2, 3, 4, 5, 6, 7. You'll get 1, 0, 0, 0, 0, 0, 0. 2, 3, 4, 5, 6, 7. Yes. So as x is getting closer and closer to 0, 1 over x is getting bigger and bigger and bigger. So it gets bigger and bigger and bigger without bound. So we can write that the limit. We can write that the limit as x approaches 0 from the right of 1 over x is positive infinity. Positive infinity means it gets bigger and bigger and bigger. And if we go from the left side, the limit as x approaches 0 from the left of 1 over x. So from the left side, we can just go to the negative values. So this just becomes negative, and this will be negative, 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 negative. So it means that this limit is negative infinity, meaning that when x is getting closer and closer to 0 from the negative side, this function is getting bigger and bigger in the negative direction. Okay. So when we write that the limit as x approaches a of f of x is equal to infinity, we mean that whenever x is close to a but not equal to a always, then f of x is a large positive number. Or we say that as x gets closer and closer to a, f of x gets bigger and bigger without bound. It doesn't have an end. It continues to get bigger and bigger. There is no end point. We can also use other ways to say this. We can say that the limit of f of x as x approaches a is infinity. F of x becomes infinite as x approaches a, or f of x increases without bound as x approaches a. I think we can use that idea now to talk about vertical asymptotes. So if we sketch the graph of 1 over x, for example, f of x equal 1 over x, we will have something like this. You can draw this on your calculator to see. You will see here that as x is getting closer and closer to 0, the function is getting bigger and bigger, going up and also going down. Remember that the limit as x approaches 0 of 1 over x does not exist. Why? Because the left hand side is negative infinity, but the right hand side is positive infinity. So the line x equal 0 is a vertical asymptote. It's a vertical asymptote of 1 over x. And we have seen that x equals 0 is the limit of the function which gets to infinity. So, what we are saying is that the line x equal a is a vertical asymptote of f of x if at least one of these is true. The limit as x approaches a is infinity. The limit as x approaches a is negative infinity. The limit as x approaches a from the left is infinity, or the limit as x approaches a from the right, from the left is negative infinity. The limit as x approaches a from the right is infinity, or the limit as x approaches a from the left, from the right is negative infinity. If any one of these is true, then the line x equal a is a vertical asymptote. Okay, vertical asymptotes will only exist for rational functions. This means function of the form f of x equal p of x, some function divided by q of x, in which case you cannot cancel out q of x. Like this function here, 2x all over x minus 3 has a vertical asymptote. We can easily find the vertical asymptote. You will see that the limit as x approaches 3 of this function will be infinity. One of the limits will be infinity. You can sketch the graph to see, but always, if you are asked to find the vertical asymptote, just put q of x equals 0 and look for x. So if ever you are asked to find the vertical asymptote, just take what is in the denominator, put this equal to 0 and look for x. So you have x minus 3 equals 0. This means x equals 3. So x equals 3 is the vertical asymptote here. X equals 3 is the vertical asymptote. How about y equal tan x? Of course, f of x equal tan x is the same as sine x over cos x, and we simply take the denominator and equate it to 0. So cos x equals 0. This gives us x is what? 0.pi over 2, 3 pi over 2, 5 pi over 2, and so on. Of course, if you draw the graph of y equal tan x, you will see exactly how this looks like. Y equal tan x will look something like this. This is negative pi over 2, and that is a vertical asymptote. This is pi over 2, another vertical asymptote. You can go up to 3 pi over 2. The graph again looks something like that. So there's another vertical asymptote there, and you can continue. Okay, download the worksheets, the textbook page number below and solve question 27 to 34. Thank you.